Welcome to the Sigma Platform demo. My name is Richard, I'm with Artec Services, and I will be your guide as we explore the ins and outs of the Sigma automation and orchestration capabilities. Today, we'll be automating VMware vCenter objects focusing on virtual machine management and configuration automation. We'll be integrating multiple environments, including AI and ITSM, to enrich the automation capability. To get started, I've already joined the Sigma platform to my Active Directory environment. This allows me to authenticate using my AD credentials. To start, we'll go to the Environments tab and connect environments that we'll be automating today. We'll start with the compute environment. We'll choose the VMware vCenter environment. In the address field, we'll type the address for where VMware vCenter lives. We'll give it a name. As far as authentication, I'll actually use my single sign-on credentials that I have used to log into the Sigma app for the vCenter connection as well. Once we test the connection, if it's successful, we'll see it added under the Compute tab, and we'll also see it under the Compute section of the Environments page. Before we go to the Compute page, we will go ahead and add an ITSM and an AI environment. For today, we'll be using a Jira environment for ITSM. We'll supply the Jira instance address, and we'll also give that a name. As far as authenticating into the Jira integration, we'll use the username and an API key that we can retrieve from the Jira site. Looks like that successfully added. And we'll go ahead and do the last environment, which will be AI. We'll use ChatGPT for this demo. Similarly, we'll provide a name for the environment. And we'll simply enter the API key that we can get from the OpenAI portal. Alright, it looks like all three environments successfully integrated into the Sigma application. We'll head to the dashboard. Now the idea behind the dashboard is to be a one-stop shop for a quick view of the connected environments, resource utilization, and alerts. We track the number of VMs that are turned on or turned off, as an example, along with host utilization. From the dashboard, you're able to go directly to the resource you're interested in to further look at alerts or any further details, or trigger any automation. It looks like we have an alert on the vCenter. We can simply click on the alert, and that will take us back to the vCenter automation page. Under the Options tab, we can enable the AI integration that we have already connected to Sigma. Now that we've enabled AI integration, we can click on the alert to get more information about it, as well as possible suggestions to resolve it. Here we see more information about the alert, and ChatGPT also gives us a few steps that we can follow in order to try to resolve the alert. Another tab we see is the Utilization tab. This will show the overall utilization for CPU, memory, and storage across all clusters and all hosts for this specific vCenter. We can hover over for more information. Let's expand the tree. You may notice it's slightly similar to how VMware's vCenter shows their hierarchy. The major difference is the ability to select multiple objects of the same type simultaneously and run automation workbooks against them. If you're familiar with the different views in vCenter, for example, Sigma tries to make the best of all the views. The VMs are under a folder called the VM folder, while the hosts and clusters are sorted at the top of the tree. We'll start by looking at the clusters. For this particular lab, we only have one cluster with 2 hosts in it, and we have a standalone host as well. The cluster view shows the utilization of all its hosts combined. For the hosts, the icons in the tree are meaningful. If a host has an error or a warning, the icon will turn to an exclamation mark, and you can see the details in the General tab. As mentioned, we're able to select multiple hosts simultaneously and compare their resource utilization or their general information. We're also able to see their status if it's yellow or green or red, indicating a possible alert. We'll uncheck the hosts so that we can head to the virtual machine automation and select multiple virtual machines simultaneously. We'll look at what Sigma allows us to do on the virtual machines in a scalable way. One of the pain points to keep in mind for organizations is agent counts on endpoints. We want to use Sigma to enable functionality that would typically require an agent and overhead on the endpoint at scale. We've selected the 3 virtual machines that have already been built in vCenter. Sigma was used to automate the creation of these virtual machines. As you may have noticed, every time a selection is made, data is automatically retrieved from vCenter and displayed. This makes it very easy to compare different metrics as well as execute actions on the virtual machines. The data that's automatically collected comes from the vCenter database, so we're not running any workloads on the virtual machines themselves from that point of view. Under General, similar to the hosts and clusters, we have some basic information about the VMs. We can sort by property or simply search for a value or a property that we might be interested in. Under the Utilization tab, we can again compare compute, memory, and storage resource utilization amongst all 3 virtual machines. Next, we'll take a look at the Remote Connect tab. The idea here is to connect to our selected virtual machine session simultaneously with a single click. This allows for quick and easy remote connections all on a single page. We're able to log in and interact with each virtual machine separately. We can also toggle the full screen view for a specific virtual machine. On to quick actions. Now this tab has a magnitude of different functionality, and we'll go through them one at a time. Starting off with my favorite feature, the ability to generate and deploy scripts at scale to virtual machines. For this example, we have Windows machines, so we'll select PowerShell as our scripting language. Immediately, we have a try and catch block in our script pane, where we can insert custom code between the try and catch blocks. Alternatively, we could load previous scripts that we may have already saved to Sigma. On the top right, we have the options drop-down again. Here, we can enable AI integration, change management integration, and modify advanced settings. But we'll start with the AI integration. We've already enabled AI integration, so it looks like it's already been selected. Now, since AI integration is enabled, we're actually able to generate a script all using ChatGPT without us having to write any code. We can use natural language processing and simply describe our script. For instance, I can type get available storage percentage, and the script is automatically generated using AI. We'll review the script and ensure that there are no syntax errors or any other inappropriate code that we may need to modify. Back under Options, we'll select the Advanced tab. Here we can set custom authentication for the script to execute if the configured environment's authentication is not appropriate or sufficient for the guest operating system. Further, we can select a protocol to be used for the script execution. For now, we'll execute the script using the WinRM protocol. We'll select Next, review the details, and execute the script against the 3 virtual machines simultaneously. The return of the script is the percentage of available storage per virtual machine as we had asked the AI integration to generate. We'll toggle the protocol again to use the VMware protocol this time, using the same exact script. And we'll execute it again. We received the same return. We may have noticed that the VMware protocol may have been a little bit slower than the WinRM protocol, simply due to the execution method on the host of the virtual machine. Let's head back to the script option and draft a script to install C++. We'll describe the script. And we'll ask the bot to generate a script that will run with a silent switch. We'll also specify that the installer should be downloaded from the Microsoft site as opposed to a local install. And we'll select Generate. Again, we'll review the script and we'll ensure that all looks well. We'll toggle back to the WinRM protocol and we'll enable change integration. We'll select our ITSM environment that we previously integrated, and that will give us the options to select a project for that specific Jira instance. Once a project is selected, we'll then select the Jira issue that we're interested to integrate with. Next, we'll execute the script. And await the return. It appears that the return returned the name of the executable along with a successful message. We'll head back to the Remote Connect tab to ensure that C++ got installed appropriately. We can see that it was installed successfully on all virtual machines. Now that we've validated a successful installation, we can upload the result to our change record by clicking on the Upload button. We get a notification that the upload to the change record was successful. And if we visit the Jira site and go to the appropriate ticket, we can find an attachment added to the ticket by Sigma with the result of the execution on each VM. Now, if we had an executable that we wanted to deploy and provide an install switch for, we may use the Packages tab. I've already imported the .NET installer and specified the destination path as well as any optional arguments. We'll execute the installers on the 3 virtual machines. The results are displayed to show the deploy status, execution status, and any return codes from the executable as well. It appears that the install was successful and an execution return code 0 was returned by the virtual machines. If we head back to the remote tab, we can again see that C++ was successfully installed by the package deployment. The next functionality we want to cover today is the file system functionality. This is a straightforward functionality. It offers the ability to walk through the file systems on each virtual machine using one view. Further, we can retrieve or delete certain files on the file system. When we select a file on the file system, we retrieve the information of that item as well, the size, type, created and modified dates, as well as the hidden attribute. We may also delete the file or retrieve it. We'll go ahead and retrieve this specific file, or we'll choose a smaller file. And we can see that the file gets downloaded locally to the browser. Alternatively, we may delete it. Again, this provides the ability to browse multiple file systems on the virtual machines on a single web page while using the VMware protocol. Looking at the Processes tab, this data was gathered back when the virtual machines were first selected. The really cool thing about this tab is that we can directly interact with the processes. We can kill them, and if we have the AI integration enabled, then we can also get general information about the processes. Here's an example. The VMtools d.exe process that's running on this virtual machine returns information from the OpenAI integration about the process. Under the Process Utilization tab, we can retrieve the top processes on the virtual machines by CPU and memory consumption. Again, we're able to do so at scale. On the security front, we've implemented a couple of very useful features. Again, we think about the multitude of agents typically required to be installed on an endpoint for things like patch management and benchmark testing. And although this is by no means a full replacement for either modules, it serves as a quick way to bring a newly built VM up to security standards, for instance. Looking at patches, we can run a patch scan on all the selected VMs to identify any missing patches. This will take a few seconds. Here are the missing patches that are required per virtual machine. We're able to select which patches we'd like to install and execute them simultaneously remotely. Once we select the desired patches, we'll simply click the Install Patches button, and this will commence the installation of these patches remotely on the virtual machines. As far as options, again, we can utilize the Change Management plugin to upload the patch results to a specific change, and we can also export a local copy, an Excel file or a CSV file of the results once the patching results come back from the virtual machines. That is simply done using these buttons. And then a report can be shared. Over to the benchmarks. We believe that there is a value in quickly running a CIS scan on a virtual machine and logging the results as part of a VM build process, or simply to mitigate a finding. We have some options to filter on the severity for CIS scans that we can also toggle. For instance, we may want to exclude low CIS scans. Again, we can select specific authentication or change the protocol for the scan itself. This will list out all of the CIS benchmarks and the test results per virtual machine. Again, we can use the table to compare specific finding results between the selected VMs and sort by criticality. As we can see, it looks like we have one high finding per virtual machine, and that is for BitLocker drive encryption. Moving on to hardware. Here we can see the existing hardware configurations for the selected virtual machines, and we can also modify them as well. We can see the configuration for CPU, memory, hard disks, as well as the controller and network details. Let's add a hard disk to our selected virtual machines. We'll select a 2 GB SCSI disk. We will leave the default partition style as GPT. For bus and unit, we can only select out of the available options. In other words, we can see that bus 0, unit 0 is taken already on all 3 virtual machines, so unit 0 would not be available for selection. We can also initialize the disk in the guest operating system and format it, as well as give the disk a new label. Once we toggle the Format Disk button, we are interacting with the virtual machines to retrieve a list of existing drive letters and other details on the disks of the virtual machines. Similar to the bus and unit drop-downs, we'll only be able to select a drive letter that is not already used by any of the virtual machines. In this case, we'll select the H letter. We'll give the hard disk label a name, and we'll simply click on Create. Adding the drives in VMware is a quick task. However, initializing all the different drives in their respective virtual machines takes a few more seconds. So I suspect this to take around 30 to 45 seconds. It looks like all 3 drives were successfully added. We can head back to the Remote Connect tab and take a look. We can see the drives not only added to the virtual machine but also initialized with the corresponding drive letter and label. This is true for all 3 virtual machines. If we head over to the CPU tab and we try to change the CPU count on the 3 virtual machines, this attempt fails quickly. When we hover over the failure, we are notified that this change cannot happen while the virtual machine is turned on. This is because CPU hot add is not enabled. To resolve this, we will need to power off the virtual machines, make the CPU modifications, and then turn them back on. This is where the task sequence can be used. We'll go to the task sequence tab and we'll create 3 tasks in order. The first task will be to power off the virtual machines. The second task will be to modify the CPU configuration. And then the third task will be to power them on. We'll select Next, Execute. On the Review tab here, we can also see the task sequence in order and review all the details before we execute. The task sequence runs one virtual machine at a time. It appears that the task sequence was successful for all 3 virtual machines. If we head back to the Quick Actions tab and we simply refresh the tree, if we go to the CPU tab, we can now see that the count is 4 for each virtual machine that we have selected. And if we go over to the Remote Connect tab and we reconnect, we can see that the virtual machines are restarting. Next, we'll head over to the VM Build Automation tab and create new virtual machines. The VM Build Automation tab allows us to build multiple virtual machines with a single wizard. To start, we'll simply create new virtual machines without using a template. We'll select to create 4 new virtual machines. On the first step of the wizard, we'll also select the location or the target folder where the virtual machines will reside. Again, we have the option to upload the change management result of the VM build to an existing change record. For the second step of the new virtual machine build, we'll select the operating system family and the guest operating system. On the third step, we'll select the compute resource. Upon selection, a compatibility check is ran against the vCenter environment to ensure that we are able to complete this build successfully. The results are displayed under the compatibility column. For step 4, we'll select the storage. We also have the data storage details in this table so that we can ensure that we have the space we need and the data type that we expect. For step 5, we can customize hardware, CPU, and memory. On the confirmation page, we can review our selections and ensure that everything looks good. Once we're ready, we'll select the Create button. Since this is a new virtual machine build, without using a template, the build should be fairly quick. Under the status column, we'll see a status update, and it looks like the build out has already been completed. We can head back to the Home tab and refresh the tree to view the newly created virtual machines. We can then select the newly created virtual machines and interact with them or run any automation we'd like. We'll power them on and head to the Remote Connect tab and simply launch their web consoles. We can see that the virtual machines are starting. We'll go ahead and power them off and delete them. Just like that, we've created 3 new virtual machines, ran tasks against them, and deleted them within a matter of seconds. We'll head back to the VM build automation, and we'll run a new automation using a template this time. We'll select 3 new virtual machines to be created. We'll keep the same folder selection. For the second step, this time, we'll select a template. We have the option to choose from Content Library or Data Center. We'll navigate to our desired template. In this case, we'll choose a Windows template. On the right-hand side, we have the option to power on the virtual machines after creation, to customize the hardware if it's different than the template, and to customize the configuration. Again, on step 3, we'll run compatibility checks against the compute resource where we'd like for these virtual machines to reside. As we can see, the compatibility checks succeeded and we're able to proceed. Again, we'll select the storage for these virtual machines. For step 5, since we enabled configuration management, we have the ability to configure the configuration of these virtual machines and join them to the domain, as well as set their network options. For the domain join, we'll want to ensure that the credentials supplied have the ability to join these virtual machines to the domain. For the IP address field, the supplied IP address will be utilized to build out the first virtual machine. All subsequent virtual machines will simply increment by 1 to the IP address. We'll provide the subnet mask, our gateway, our DNS server, and our DNS domain. Under application configuration, we may select an application from our database or use AI to generate new application configuration suggestions for our virtual machine builds. On the confirmation page, we'll review our selections and ensure everything looks good. We'll select the Create button. This will trigger the vCenter task to create these virtual machines. Again, under the status column, we'll be able to keep an eye on the progress of this build out. This build out will take a little bit longer than the previous build out because we're using a template and we're running custom configurations. Alright, it looks like the build out has been completed. Again, we can head back to the Home tab and refresh the tree. And we can see the newly created virtual machines, and we can also see that they are on by the icon. We can head to the Remote Connect tab, and we'll give them a couple minutes to install their configuration that we specified. We can see that the virtual machines are restarting, which is a good indication that the configuration is applying. Once the virtual machines restart, we can see that the network is connected and we're able to log in using domain credentials. This indicates that the configuration installation was successful. We can verify that the IP address matches the configuration IP address provided. Again, we may head to the Quick Actions tab and run any automation playbooks that we'd like. We'll power the VMs off and delete them. We'll refresh the tree. And we can see that the virtual machines have been deleted. This concludes the demo for today. Thank you for watching.